This video is going to be entitled Commentary on Euclid's Book 7 Definitions Part 1. There's definitely going to be more than one part to this, and that's because what we're going to be covering is so much more extensive than what Euclid actually covered in his definitions. Now, first of all, we have to establish a few concepts here. We're going to be using Euclid's magnitudes to discuss what Euclid said, and then we're going to turn it around and we're going to use ticker tape to illustrate what we're trying to say to you. And the we we're talking about here, I am getting assistance from Booball1067, so together we're going to actually present you something higher level than what Euclid originally pronounced in his Elements. Okay. Remember, Euclid is a good starting point, but he's not the finish. He's not the end. Alright? So, first of all, Euclid thought of the number 1 as a unit. He did not actually consider the number 1 as a number. So therefore, the number 1 to him was not prime. It also was not an odd number. Isn't that nice? Euclid did not consider the number 1 as an odd number, because he didn't consider the number 1 as a number. So anyway, now you also have to keep in mind that mathematicians of that caliber did not say, well, this is the number 0. That was not the way they considered it. Their thinking was that 0 was a representation of the absence of value. It was something that was worth nothing. This is very important in statistics, accounting, and high levels of mathematics. You're no longer just saying that's a pretty little number. It's, oh, look at the little circle with the line through. And yes, when you are actually doing high levels of data processing, you will actually make a circle with a line through it, because otherwise it's just nothing but a circle. Or the letter O. And you get that confused. So, when you're drawing a real 0, you have to put a line through it. A diagonal line. But to statisticians, accountants, and people into high-level mathematics, if you are saying the number 0, you are actually saying you have something out there that's worth nothing. Like a broken shoestring. A broken shoestring would be really worth 0, because who's going to buy a broken shoestring? It's not going to happen. Alright? So, now you say, well, what's a ticker tape? Well, I'm going to put a picture, I'm going to put a link to a picture of a ticker tape right down here in the links below, and you can see this for yourself. Alright? Now then, I don't have ticker tape, but what I do have is this. Measuring tape. Okay? Now, if this was more of a fabric type, we'd actually bend the measuring tape here to show overlapping. Okay? And that's what we're going to do here. Alright? Now, Euclid did not really overlap as you would understand. He would overlay things. Okay, he would overlay units. But remember, what I said in my last video is that units can actually represent number sets. Okay, it's just like I said, you have these 4 buckets, and each bucket have 20 bricks apiece in them. Well, we can still say we have 4 units, even though each unit has 20 bricks inside. See the difference? Okay, so that units do not have to be the physical number 1. Doesn't work that way in modern math. You know, we're talking about high levels, calculus type math. Units do not work as just the number 1. It doesn't work that way. Alright? Now let's go on with Euclid's definitions, and we'll try to use Euclid's magnitudes. Now keep in mind, Euclid's magnitudes were not like, they draw them as lines in books, but Euclid used other things besides just lines to illustrate magnitudes. Okay? You can have a magnitude in buildings. The height of the building can be a magnitude. So obviously it's not just a line, but usually it's represented by the line because that's the easiest thing for kids to pick up. Alright? Now, definition number 8 said an even times even number is that which is measured by an even number according to an even number. Alright? So we have the 2 times the 2. we're measuring by units of 2. We have 2 units of 2, and that's where we get the 4. Okay? 4 is 2 units of 2. Alright? So imagine it this way. You have 2 buckets, and each bucket has 2 bricks inside. 2 units of 2. An even times odd number is that which is measured by an even number according to an odd number. So now what you have is units of 3, and you have 2 units of 3. Get the picture? You have actually 2 units of 3. 9 here is 3 units of 3. Now, that goes with definition number 10, which says an odd times odd number is that which is measured by an odd number according to an odd number. Alright? Now, you can discover all the even numbers, all the even times even numbers, all the even time odd numbers, and all the odd time odd numbers through ticker tape. Okay? And this is where you do the overlapping. What happens is you divide your ticker tape into units of 2, and you can then overlap. Okay, you can take the actual 2. Remember, the 2 itself is not divisible because you're actually using that as a unit. That's your unit measure. So you're not going to divide your unit measure. Okay? Whatever your unit measure is, you're not going to divide it. It's just like when I said you had 4 buckets, and each bucket had 20 bricks apiece. You're not going to take any bricks out of the bucket, and you're not going to put any bricks inside the bucket, so you're not going to do any dividing or multiplying in the bucket. You're just going to consider the bucket as a unit. Alright? So, you can have this big old ticker tape line divided up into units of 2, and that would give you your even numbers. And then to overlap, you can actually overlap that first 2 by 1, thus making the 2 somewhere between -1 and +1, overlapping at the 0, and then discovering your odd numbers and your even times even numbers, even times odd numbers, and odd times odd numbers. Now, when I continue this commentary, I'm going to further illustrate what I'm talking about. It's just, it's within the presentation. We're trying to make sure you understand this correctly. But like I said, we can actually, through a ticker tape, overlap. Okay? Something like this. We can actually overlap. And that's what we do here. So what you would be saying, as best as I understand this, is if you're going to do the overlapping method, you've got a number line, or a ticker tape as we're saying here. It's all been divided into units of 2. But what we're going to do, because here's your 1, extend this out just a little bit. Well, here's your 0. Here's your -1. What we're going to do is we're going to take this unit, which is between 0 and 2, we're going to overlap it, so that now it covers -1 to +1. Okay? Instead of it being between 0 and 2, the unit will be moved back between -1 and +1, and thus giving you your odd number system. And it's because of those overlappings that's where you're going to start getting your even times even number, even times odd numbers, and odd times odd numbers. You're going to have all that overlapping, and eventually you'll be able to see these numbers for yourself. And I will further elaborate on this in my next video, and hopefully be able to tell you more. Alright? So, stay tuned. There's a lot more to come.